This video will go through slab shear in the SLB software. This is one-way beam shear as it applies to the design of slabs. So this is AS3600 section 8. Now note, this is not the same as punching shear, which is covered in section 9 and gone through in detail in a separate video. The SLB software has two different ways of calculating the slab shear. So slab shear derived from the bending moment, which will give us indicative results, and slab shear calculated directly via thick plate theory. And then we'll show how to design the slab for shear using the wide beam tool. So going to the SLB software, we're going to look at a transfer floor where this is of particular concern. So this has been exported from the RCB software with reactions from above. So if we go to the primary load case, we zoom in, we see we have some line loads for partitions, but we have reactions that are coming down on the columns above. And if we go to the live load, similarly here as well. So if we go to home and 3D view, we can see a 3D render of the floor that we're going to be designing. So no beam option has been chosen here. We have just a thicker slab zone of about 500 thick. So in this case, why we need to consider it, the columns are very close to the support, so the load is basically it's going to be transferring in shear, not so much in bending. And basically we're only about a meter and a half, 2 meters away from the columns above to the supports under. So the first thing we need to check is, well, do we have a potential shear problem? Now, how we do this in slab zones, there's one of two ways. If we switch off the loading, we go to results, we look at slab shear, we can look at it via indicative, so basically that means it's derived from the bending moments, or by thick plate theory. So to show the indicative results, we have to show the bending moment. So we'll do the worst case ultimate axial, hit bending moment in the Y. We have some values here on screen, and then we go slab shear indicative, so derived from the bending moments. Now this may take a bit of time because this is a post-process calculated after the analysis. So we zoom into this area, make the text smaller. We can see a few values in red. What this is, the program is checking the capacity of just the concrete itself for shear. So this red indicates that in the Y direction we could have potential shear failure in this zone. So again, these values are just indicative. So the type of analysis performed in the SLB software is basically thin plate finite element analysis. So we use a discrete Kirchhoff triangular element. This type of element neglects traverse shear deformation, and basically the nodal shear values calculated by the Kirchhoff element thin plate option are derived from the bending moment. So they are just indicative, but it can be used just to quickly give us an indication of any areas that could potentially have issues. To calculate shear directly, we use a different type of element, the Mendelin-Reisner element. So this basically calculates shear deformation correctly, and typically it should be used when we have slabs that are thicker than sort of 400, 500, 600 mil. So that's for our case. So for this very thick 500 thick slab zone. To do the thick plate, to show the thick plate theory, we go to slab shear by thick plate theory. However, before we run this, we make sure that under settings, models and solvers, we have switched on slab shear by thick plate theory. So in this case it's on. To show the results for slab shear by thick plate theory, we go to slab shear and then select the Y. So again, this is run as a post process, so it might take a bit of time. And we see a few red dots in the areas that we saw previously, but the results now should be much more accurate. Pressing within these finite element nodes, we see the capacity here in the properties window, but the key difference now is obviously the results are more accurate, but we're also considering the tensile steel that is in that particular finite element node. So the tensile steel being the design reinforcement as calculated by the software. How the program is calculating reinforcement is covered in different videos. So we have a more accurate method of calculating the results, and the result is considering both the capacity of the concrete and the steel. The red circles indicates that both our concrete and the steel that we've designed is not sufficient in these areas. Now, how we could design this, we can use the basically the wide beam integration tool to design and detail this area as if it were a beam. So as mentioned in the beam video, the wide beam tool is simply an area of integration. So we just select it, define with 2 points, specify in between these columns, and make some width. So we'll put 2 meters wide, say. Again, we haven't lost the results because we haven't changed the structure. We've just drawn an area over which we want to integrate. So if we now go to results and we select wide beam, so there's only one drawn, we don't need to select it, hit envelope design, number 1, and we open up the report. The program has basically found the shear force for us in that area and designed it to us to section 8. We would then perform the same checks for the other direction in the Y. Now, a summary of what we learnt in this video, what we covered. We looked at one-way beam shear as it applies to slabs. So this is potentially an issue for heavily loaded two-way flat plate transfer slabs. So where the transfer load from the columns walls above will be transferring through in shear to the supports below. Now note, this is not the same as punching shear. We can check this using one of 2 methods. We can look at the indicative slab shear, so that's derived from the bending moment, which is calculated using the discrete Kirchhoff element, and again this is only checking the capacity of the concrete alone. Or we could use the more accurate slab shear by thick plate theory, where we directly calculate the shear using the Mendlin-Reisner finite element, which is providing more accurate results. And this element is also considering both the capacity of the concrete and the capacity of the tensile steel. We can then design a slab for shear using the wide beam tool. This concludes this video. Thank you for watching.